61?
Good one, good one.
61, and we'll do as many as we can do, because I want you to understand them. But you got to stay focused. This is a good problem right here. We're not going to have to stop already, are we, folks? I think we're going to stop.
You can't trust her. She is here.
A 20-foot ladder leans against a wall so that the base of the ladder is 8 feet from the base of the building. What angle does the ladder make with the ground? This is a good problem because I know these are the kind of problems I put on the test. So you might want to watch closely. What do I need to draw first?
The 20-foot, the 8 foot from the wall.
So we're,
The bottom, the base.
okay, so if I draw this, that's 8 foot.
And the wall goes straight
The wall goes straight up. Then what?
The ladder leaning against it.
All right, so you got a ladder leaning against it. Do we really need to draw it so it looks like a ladder?
No.
No. All right, make sure it's leaning. What do we know about this angle?
Oh, wait, it's right.
Okay, and the ladder is, the hypotenuse, it's 20 feet, right? What angle does the ladder make with the ground?
Right angle.
First, now does the ladder make a right angle with the ground?
Oh, no.
No. Now, so we're looking for this angle right here. All right? Do we know for sure what it is? No, but we're going to be able to find it. Normally, if we were doing a problem like this, we wouldn't be looking for the angle. You don't really care when you lean a ladder up against the wall. You don't really care what angle it makes with the ground. I mean, you don't want it to be such a big angle that it's going to fall on you, or such a small angle. I'm saying that backwards. Such a big angle that it's going to tip backwards on you, or such a small angle it's going to slide down the wall on you, right? But do you really care if it's a 50-degree angle or a 30-degree angle or a 20? Not really. So normally we wouldn't be finding this. Normally we would be finding what in this triangle? This other side, right? Because we want to know how far up the wall that ladder is going to reach. If our eave spouts are 12 feet off the ground, we'd want to know if that 20-foot ladder is going to be enough to get us up there so we can clean out our eave spouts or whatever it is that we're working on. Or so that we can paint the trim on the top of our house or whatever it happens to be. So normally we'd be looking for that side right there. This time we're not. If we were looking for that side right there, would we have to use the trig ratios like we've been doing? No. What could we use? Pythagorean theorem. And that's going to be part of the test is you got to figure out, hey, if I'm given this triangle, if I'm looking for this side, what do I need to use? If I'm looking for this angle, what do I need to use? So you got to be able to do that. This time we're looking for this angle. So what we're going to do, first thing we're going to do, got all this written right over here. Label the triangle. How am I going to label this triangle if I'm looking for that angle? What's that side going to be labeled? It's across from that certain angle that we're dealing with, so it's called the opposite. Got to be able to do this. That's the opposite. What's the side across from the right angle called? The hypotenuse always. And then the third side is the adjacent. We really only care about two of those sides this time. Which one don't we care about? We don't. Which one's it? Which one?
Opposite.
The opposite. We don't care about the opposite because they didn't tell us anything about the opposite. Okay? So now we're looking at this, and this is where most of you have the biggest trouble. So Hunter's going to make sure he's watching real close right here. We don't care about the opposite. We do care about the adjacent and the hypotenuse. Which trig ratio deals with those two? Cosine. Is that right? Everybody agree with that? So guess which trig ratio we use? Cosine. And you're going to do this right here. This is what we're going to do. Write down the trig ratio, write down the angle, write down the equal sign, write down the fraction. That's how we write our equation each time for all these problems on this paper. Every one of them. Those four things. What trig ratio did you tell me to write down? Cosine. Then we write down the angle. What's our angle this time? We don't know. So x equals, that's the hardest part, right? It's writing the equal sign. You're just kidding, right, Lexi? You're not being serious. Then the fraction. For cosine, what is it? What over what? Adjacent over hypotenuse, so 8 over 20. Anytime you're looking for an angle, you're trying to find an angle, and you're looking for that angle, what's the first thing you're going to hit on your calculator? Except if it's even. Second. You're going to hit second first thing. That's the only time you're going to hit second, is when we're looking for an angle. Okay? So on our calculator, all we do, we hit second. These are the buttons you hit on your calculator. You should probably be following along and doing it. Make sure you understand it. You hit second, then what do you hit next? Cosine. Then you punch in 8 divided by, close the parenthesis, then you hit equals or enter, whichever one your calculator has. And we probably will round it off. I don't know if they told us.
Yeah, they said 10 years.
Angle measure to the nearest degree. So what's the nearest degree on this one? So what's the measure of that angle that makes with the ground right there? 66. Could we find the angle it makes with the wall up there? If we now know that this is 66 degrees,
Just take 66 or close 90 minus.
subtract all that from 180 and we could find it pretty easy, right?
So what do? I do 8 divided by 20.
So on yours you do 8 divided by 20, second cosine. So you start here.
It says air.
You did something wrong there.
What do you mean?
8 divided by 20. 8 divided by 20 equals. You gotta hit the equals.
Oh, okay.
Then you hit second cosine.
It was like.
Did everybody get 66? Because if you didn't get 66, then maybe your calculator's set wrong, and I need to fix it. It's not in degrees, or it's not in the correct units.
Mm-hmm.
Next question.
62.
62. A 50-meter vertical tower is braced with a cable secured at the top of the tower and tied 30 meters from the base. What angle does the cable form with the vertical tower? So how am I going to draw this? What do I need to draw?
Right triangle.
Draw a right triangle. It's going to end up looking something like that maybe.
The base is 30.
This is the what in our picture?
the vertical.
That's the
Vertical tower.
tower. This is the
Cable.
cable. So you got your tower, you got your cable. We know that that's a right angle. Hopefully the cable or the tower makes a right angle with the ground. Right, Chloe?
Yep.
Focus, Chloe. We could take, no, you're not. We could take the test today. What goes right here?
50 meters.
50 meters. Because it seems like I might be wasting my time if you're not paying attention.
30 meters in the bottom.
30 meters on the bottom. And that's all they tell us. What are we looking for?
The angle on the top.
The angle on the top. So we're looking for that angle right there. Again, I don't know why you'd be looking for this angle really. Doesn't make sense. You probably want to know the length of the cable. So we could, if we were just going to find the length of the cable, we could use what? Pythagorean theorem, right? But this time they wanted us to find this angle.
That means the side that has the 30 meters would be the opposite.
So that's the opposite. So we label that first. That's the first thing we do is label. What's this side? Hypotenuse. What's this side?
Adjacent.
Which side don't we care about? Don't we care anything about the hypotenuse? Which trig ratio are we going to be using then? The tangent. Good. So we write down, we just do this right here. Every problem on this whole packet, this is what you do. You write tan,
Why would you say it?
because we opposite and adjacent. So we look over here, one that deals with opposite and adjacent. It's the tangent. So tan, what's our angle?
30x.
X equals
50.
30 over 50. Everybody agree with that? Opposite over adjacent, which is 30 over 50. We're looking for an angle again, right? So what do you punch in on your calculator first? So you hit second. Second. Then what do you hit? tangent,
30 divided by 50.
30 divided by 50, close the parenthesis,
30.96. 31.
31 degrees. Everybody get that?
Yeah.
That's what everybody got?
Yeah.
Evan, you got yours doing it the other way? So to measure this angle right here, the angle that the cable makes with the tower there, 31 degrees. Remember, that's the only time when you set up your equation. Every problem you're going to set up the equation. But the only time you're going to use second is when you don't know the angle, when you're looking for the angle. Other questions?
30 or 65.
65. Richard is flying a kite. The kite string makes an angle of 57 degrees with the ground. If Richard is standing 100 feet from the point on the ground directly below the kite, find the length of the kite string. So how am I going to draw this?
You draw a kite.
Draw a kite,
Draw string.
string, comes probably down like that, right?
Yeah.
Now what?
Person.
Person.
Put 100 somewhere.
Then the kite string makes it 57
No, because he's standing.
degree with the ground.
So the kite string comes down here. So what else do I need to draw before I make that angle?
Under the kite.
He's directly under the kite.
I need to draw this, and this angle right here is what?
53 degrees.
57.
57. And then they said there's some spot out here that's directly below the kite. What do we know about it?
He's 100 feet away.
He's 100 feet from it. What do we know about this angle right here?
Right.
The right angle. What are we looking for?
The length of the string.
Where's that at?
Right.
The hypotenuse of this, so that's going to be our x this time. Got to be able to draw these pictures, all right? Now, could you just about every time draw some right triangle and then just fill in the numbers? Yeah, as long as you don't mess up and, you know, say that the 100 feet is here or the 100 feet is here. You got to know where it goes at in relationship to the problem. Which angle are we going to deal with this time?
One under the kite.
This one?
The 57.
Why the 57?
Because that's the angle.
That's the angle that they told us. Use what you know. We could use this one, but what would we have to do?
Find it.
Find it. Do we really want to go through the extra work if we don't have to? So now, next thing I do is I label the triangle. What's this side going to be labeled?
Opposite.
Opposite. How about that side? Hypotenuse. This side over here is the adjacent. Which side do we really not care about this time? I heard two different answers.
Yeah.
How do you know which ones you care about and which ones you don't? Because you guys seem to have trouble with that.
Both doesn't have an angle.
Then
Doesn't
sides
have
don't
a
have,
number,
A number, yeah.
doesn't have any information. All right? We know this one. We want to keep as many numbers in our problem as possible, right? Because that makes it easier. We're looking for that one. Do we know this one? Do we want to find it? No, they didn't ask us to find it. So which one don't we care about?
Opposite.
The opposite. Now we look at these two. Which trig ratio deals with adjacent and hypotenuse? Cosine. So what do I write down first here?
Cosine.
Cosine. What's our angle?
100. Or 57.
57 equals, what's our ratio? Adjacent over hypotenuse, right? So what's adjacent? 100. What's the hypotenuse? Now watching closely on this is different because are we finding an angle this time? So is Lexi going to hit second first on her calculator? No. First thing she's going to hit on her calculator, she's going to figure out what the cosine of 57 is. So grab your calculator and figure out what the cosine of 57 is. It's going to give you some decimal. What is it?
154.
Remember, how many places do we go out? 4 places when we're finding cosine, sine, or tangent, right? So tell it to me again.
54, 46.
54, 46. Everybody agree with that? Is that right?
Number
On yours, put in 57, then hit cosine, right? And this is 100 over x. Notice I haven't changed the right side yet.
Over.
Austin's telling us to put that over 1. Everybody agree with that?
Yes.
Yeah. And now you cross multiply. Now, the reason Austin's saying no is because he's thinking, oh crap. When I multiply here, I got 1 times 100. What's 1 times 100? 100. He's used to the x being on top here and just getting 1 times x, and that's all you got to do. This one's a little harder because you actually got to do an extra step after you cross multiply.
Yeah, you got it.
So we cross multiply this way, we get 100 equals, you multiply this way, what's that give us?
Wait.
0.5446, keep going, x. Now, how do you solve for x?
Divide by 100.
Divide both sides by 100?
No, 0.5446.
Divide both sides by 0.5446. Now, somebody yesterday told me, before you grab your calculator, don't punch it in yet, stop. Somebody yesterday told me, well, when you're dividing with 100, all you do is bump the decimal over 2 places. Is that true on this problem? That's when you're dividing by 100. When you got 100 divided by. Now, don't punch it in yet, stop. Because before you punch something in, you should know, use your head a little bit, what's it going to give me when I punch it in? Because if you're just counting on your calculator to give you the right answer, then you're doing something stupid. Because the calculator is only as smart as what? The person punching the buttons, right? So if you punch in the wrong buttons, what's it going to give you? The wrong answer. So when I look at this and it says about 0.5. If I'm dividing 100 by 0.5, so if I had $100 laying here, if I had $100 and I told Kenneth to lay it in 100 piles, how much would be in each pile?
Probably only like 1
$1, right? $1. Now, when I tell you to split it up into piles of $50, how many piles are you going to have? 200. So what happened to the number? It went up. So when I divide this, what should happen to my 100? It should get bigger. And I should know, hey, it's going to be somewhere around 200 or fairly close to 200. Now divide it on your calculators. 183.6. Anybody else get that? What's 183.6? What is that? Explain it for the problem. The kite string. So we got 183.6 feet of string out. 183.6 feet of string out.
I have 2 feet in my house, I can't do a kite.
Next question. 60? Be ready to ask because I'm about done. Problem 60. To secure a 500-meter radio tower against high winds, a guy wire. All a guy wire is, if you look at a telephone pole and it's got a wire hooked to it, that's a guy wire. G-U-Y. I'm not sure why it's not called a guide wire. That would seem to make more sense, right? Because it sort of keeps it up, but it's called a guy wire. Attached to a ring 5 meters from the top of the tower, the wires form a 15-degree angle with the tower. Find the distance from the tower to the guy wire anchor on the ground. Do I really need both triangles?
No.
No. So if I draw this, just draw one of the triangles that they have there. We know that the whole tower is how long? Or how tall? 500 meters, right? So that's that whole thing there. And we know that this angle up here is 15 degrees. That's in the picture, right? And we know that this top part right here is 5 meters. We're hoping that this angle right here the tower makes with the ground is what? The angle the tower makes with the ground, we're hoping it's what? 90?
Yeah.
So let's put that in there. They said we're looking for D, which is this distance. How far is it from the tower to this anchor out here? Well, it doesn't look like we know enough information, because in our triangle, we don't know any of the sides. Because is this 500 in the triangle? No. What is in the triangle though? Is the 5 in the triangle? The 15 is, but we need a side. How can we find the other side? Or how can we find a side? Because we're in this triangle right here. How can we find one of the sides there? Because we don't know any of them. You gotta do something before you can start what we've been doing.
You can find one on the side.
So which side are we gonna find? This side? No? This side? We know some information about this side, don't we? How can we find from here, the distance from here to there?
Minus 505.
500 minus 5, what do you end up with? 495. So you gotta make sure you do that first. Because if you use the whole 500, is it gonna give you the right answer? No. So you gotta use that first. Now, when I go to do this, next thing I'm gonna do is label my triangle. Which angle am I gonna use?
15.
Use the 15. So when I go to label this, what's that side gonna be labeled? That's your opposite. What's that side labeled? What's this side over here labeled? Jason. Right, Lexi? You understand all this? So I could have you come up and do the next crop. Always going to come up. So once I have that, which side do I care absolutely nothing about? The hypotenuse. So I'm going to get rid of it. So I'm looking at this, I'm looking at this. Which trig ratio uses those two? Which one? Tangent. So what do I write down first here? Tangent. What comes next? What's the angle? D. 15 equals, you got to be able to set this up. You got to be able to do this. All right? We went over about 5 problems now, and you guys still aren't setting up the equations, right? Because you're paying attention about half the time. Tangent 15 equals something over something. What over what?
495 over D.
495 over D. Everybody agree with that?
Or is it switched around?
I don't know. Which one is it?
It's
Oh,
D
okay,
and
it's
then
switched around.
It's opposite over. So opposite, what's the opposite side? D. What's the adjacent side? 495.
15.
What's the first thing you do once you have your equation?
15.
Wait, how would I do it on this one? On this
You're not hitting second, all right? Because we're not looking for an angle. So what's the first thing we do? Find the tangent of 15. What is the tangent of 15? 2679. Does everybody agree with that? Is that what you got, Hunter?
Yeah.
We put that over 1. Now we cross multiply. This is one of the nice ones, because when we cross multiply the first thing here, what do we get? Just 1D or just D. Then we cross multiply the other,
That's the answer.
and that's going to just be the answer.
It's 132.6
132.6.
meters.
Does it make sense for the distance from the tower to here to be 132.6 meters?
Yeah.
You see like those big phone towers and stuff that they put up, and they have guy wires on them? The wires go way out, far away from the tower. Not far, but 132 meters out, football field out or so. Next question.
Why are they called guy wires? That just doesn't sound right.
Go back. Hurry up. 56 is probably about the last one, so if you got questions, you better be ready to ask. 56, a surveyor is 100 meters from a building. He finds the angle of elevation to the top of the building is 23 degrees. Remember your angle of elevation, if I'm standing here looking straight out, angle of elevation Where's my right arm gonna move to? Up. Angle of elevation, if it's angle of depression, my right arm is gonna move down. So his angle of elevation, now I'm just gonna draw the triangle here, not drawing everything else, is 23 degrees. He's 100 meters from the building. What do we know about this angle right here? It's a right angle. If the surveyor's eye level is 1.55 meters, so they're saying his eye level up to there is 1.55 meters, up to that point. Find the height of the building. So we're gonna find this height over here. The bad thing is, are we just finding that side of the triangle? What do we gotta remember to
The
do?
bottom part,
Add on
which is easy.
that 1.55 at the end, right? So at the end here, we're gonna add 1.55 meters. Once we find out what X is. Which angle am I gonna be dealing with here?
23.
The 23. So when I go to label this triangle, what's that side gonna be labeled? The opposite? What's this side labeled? Hypotenuse. Now when we do go to take this test, is all the triangles always gonna be labeled opposite, hypotenuse, and adjacent? No, remember with the 30, 60, 90, and the 45, 45, 90s, they were labeled something different, right? So don't get all that confused. Which side do I care absolutely nothing about this time? The hypotenuse again. Which trig ratio deals with the two that we do care about? So we do tangent. What's our angle? What is it? 23 equals x over 100. Everybody agree with that? Find the tangent of 23 on your calculator. 4244. Is that right? X over 100 still. Now what do I do? The 1 underneath that, cross multiply, what do I get going that way? Now this time, that person yesterday said, when you divide by 100, you bump the decimal over 2 places. When you multiply by 100, what do? You bump it 2 places to the right. So without even using our calculator, if we bump that over, what's our answer going to come out to be? 42.44. I don't know what they tell us to round it off to on this one. Probably 56. Anything? They say so. 42.44 meters. Does it make sense for the building to be about 42 meters tall?
We have to add that one.
Oh, so are we finished?
Oh, no.
We got to add the 1.55, don't we? So what do we do to get our answer? 42.44 plus that. What is it?
43.99.
43.99. So it's almost how much?
44 feet.
44 meters. One more before I click. 64. From the top of the lighthouse, from the top of the lighthouse, 210 feet high. The angle of depression of a boat is 27 degrees. Find the distance from the boat to the foot of the lighthouse. The lighthouse was built at sea level. So 64. Now watch on this one. We got our lighthouse. Our lighthouse, that's going to be our lighthouse. And then there's some boat out here. This is our boat, that point right there. From the top of a 210-foot lighthouse, so the lighthouse is 210 foot, I'm going to write that in. You've got to be able to do these, and this is probably the hardest one that you'd have to be able to do. It says the angle of depression to the boat is 27 degrees. Now here's where you got to be careful. When I draw in the top of the lighthouse to the boat, is that angle right there the 27 degree angle? That's not angle of depression, is it? Angle of depression is if you were standing up here, you're standing at the top of the lighthouse looking straight out, and then you look down at the boat. That's not this. Angle of depression, we'd have to draw this in. That's our angle of depression. So is it even in the triangle that we want?
No.
So that's 27 degrees. Now what I'm going to show you is, as we do this, if I did this and then drew this, what kind of shape do we have, the big shape? A rectangle. All right? It's a rectangle. What do we know about this angle right here? Watch what I'm doing. And that angle right there. They're the same. So if you're standing on the boat looking up at the lighthouse, your angle of elevation is going to be the same as the person up here's angle of depression. So what's this angle right here going to be? 27.
Then that angle would be 63.
Now we could use this angle up here because this should be a right angle. And it's got to be 63, right? Because those two together have to add up to be a right angle. That's 90 degrees there. We're looking for, what were we looking for?
Distance from the boat to the foot of the lighthouse.
So that's right here, right? That's probably, if you're on the boat, that's probably what you want to know because you don't want to get too close to the lighthouse. It's usually right on the edge. If you get too close to the lighthouse, that probably means that you do what? Crash. Which angle are we going to use this time? Does it really matter?
No.
Which one can we not use?
Right angle.
The right angle. Never use the right angle, but we can use the other two. So you pick, which one do you want to use?
27.
Or 27 first. So if we label the triangle according to the 27, what's that side going to be labeled? That's your opposite leg. What's that side going to be labeled? Hypotenuse. What's this side? Which two do we care about this time? Opposite and adjacent. Which trig ratio deals with opposite and adjacent? Does that mean, are we always going to be using tangent because that's all we picked here the last 5 problems or so? No, it just happens to be the ones you picked. So we do tangent. What's our angle? 27 equals this. Right in this equation is what you need to do on the test. When we do take this test, you draw this picture for me and label it. That's a point. You write out this whole equation. That's another point. All right. Yep. So for tangent, tangent is what over what?
Opposite or adjacent.
Opposite over adjacent. What's the opposite this time? 210. What's the adjacent? Ignore that stray mark here. What's the first thing I do once I have my equation? Find the tan of 27. So this would be a point. Be ready to tell me the tangent here in a second. This would be a point. What is the tangent of 27? Point 5095 equals 210 over x. Put this over 1. Cross multiply, what do we get? 210. What do we get going the other way? Now what? Again, when we're dividing by 0.5095, that's about divided by 0.5, which is a half. So this number should get about twice as big. So our answer should be 420, somewhere in that range. These cancel out, you're left with x equals, what's this?
412.1.
0.1.
Yep.
What's that tell us? Explain it to me in the problem.
The distance from the boat to the lighthouse.
So from the boat to the lighthouse is about 412 meters. About 412 meters.
That was like one of the hardest ones.
The only reason that one's hard, or would be hard, is because that angle of depression really isn't in the triangle. Because you're thinking of using this triangle. But if you did this, and you put that 27 in there,
It'd be the same.
it's the same triangle, except instead of looking for this side, the side down here along the water, we're looking for that side up there. So either way, the way that we did it, by moving that 27 down to here, or by just using this other triangle, either way would work out the same. But you gotta remember, Angle of depression isn't that angle right there. Angle of depression is me looking straight out, so this is one of my sides of the angle, and then looking down. That's this angle here, not me looking down and then looking straight down. That doesn't make any sense. Okay? Make sure your names are on those. You're going to lay them right here on this desk. Turn your desk back around so you can write down some of this stuff. What I wanted. What we're going to be doing today is solving triangles. Solving triangles. So it sounds strange to solve a triangle, solve equations. I'm going to explain to you what solving a triangle is. Basically, the stuff we do today is going to be the same as the stuff we've been doing, except it's like putting it all together. You guys are supposed to play eating tonight. Yeah, it is the pitch. I'm eating.
Huh? I said, are you here?
Thank you. So when you're solving a triangle, first thing you got to remember, think before you answer this, how many parts does a triangle have? 6 parts. When you're solving a triangle, what you're doing is finding all those parts. Chloe looked at it like 6. What do you mean
I get it.
6?
3 sides.
3 sides, 3 angles. All right, it's not just talking about sides, it's talking about all 6 parts. So when we're done, when we're looking at this triangle, when we're done, we're going to know this side, we're going to know this side, we're going to know this side, we're going to know this angle, we're going to know this angle, and we already know that angle because all of these have to have a right angle in them. All right? So we're going to know all 6 of those when we're done. It doesn't matter how you solve for the parts. Probably you're going to have to use sine, cosine, and tangent to find something along the line because that's the one that takes the least amount of information to find something. But then after that, you could use Pythagorean's theorem. You could use the fact that the 3 angles of a triangle have to add up to 180, so on, so on, so on. All right? You want to use the easiest thing possible. For a lot of you, Pythagorean's theorem is easy, right? So if you know 2 sides, find the 3rd side by using Pythagorean's theorem. Don't use sine, cosine, tangent. It's a little tougher. We talked about this last time. If you didn't write it down last time, some of my classes we didn't get to it before break. Angle of elevation, angle of depression. Angle of elevation, you got your eyesight going straight out. And then your eyes go up. That's an angle elevation. Angle of depression. Your eyesight's going straight out. And then you turn your eyes down to look at something down. But remember with this, because if we were doing this problem right here, looking at this boat, is that the triangle that we're probably going to deal with? We're probably going to deal with that triangle right there, right? So you have to remember that this angle of depression here is going to be the same as that angle of elevation down there because they're alternate interior angles. Or if this angle of depression was 20 degrees, we could just find this angle right here and just use it. What do we know about those two angles? They have to add up to how much? 90 degrees. So either way, with angle of elevation, usually it's not that hard because usually we're trying to find how high up the bird is off the ground or how far we are from where the bird's flying at. Probably
Not
because,
that bad.
huh?
I had like the Swiss cake. And I was like in the pool and I was about to eat it. And mom told me not to because she saw perfect on it. No, I didn't know. I was about to eat it too.
She was probably like,
No,
he probably set it down. She ate it.
No, it was the other burger one. I looked at it, I was like,
That's it.
wait,
We didn't even need that. That's pretty.
Are you serious?
I just
I just like
focused.
Well, I'm getting waste of piece of paper. Are you being serious?
Obviously.
Wasted. I just wasted like half of a tree. You just got pranked.
From you, buddy.
On this packet,
star.
we're going to do a couple of these problems together, then you're on your own.
Yeah,
So on the front it says solve each triangle. Pick me a problem 1 through 8 on the front.
but. No, stop.
Want to do number 1?
No, let's do 5.
What's the difference? Just pick one.
Let's vote.
3.
1.
Let's vote, like-
Problem 1.
So on all these, you're finding all the six.
You're finding all the parts, all the 6 parts. So what I might do, maybe this would be helpful to you. We got sides, we got angles. How many sides do we have in a triangle? 3. We already know what?
1.
One of them, 5. So we already know one of those, so how many more sides we got to find?
2.
2. So I got 2 boxes to fill there. All right, that way, just to help me make sure I get everything. How many angles do we have in a triangle? 3. How many do we know?
42.
42. That's the only one we know?
Yeah. 90.
And then 90 also, don't we? How many more angles do we need to find then?
1.
We only need to find 1 more angle. So there's 3 boxes that we got to fill to answer this whole question. All right? What's the easiest one to find? One of the sides or the angle? The angle probably this time. Why is the angle easier this time? So add them up. 90 plus 42, subtract that from 180. Grab your calculator. 48. So what's this angle right here? 48 degrees. So that's one of our answers. That angle is 48 degrees. Add them up, subtract from 180. So if you know 2 of the angles, that's probably the easiest thing to do is find the other angle first. Now we want to find one of the sides. They didn't give us any letters on this, so let's make up 2 variables. Give me a variable for this side. Z. How about this side? Y. Which one do you want to find first, Z or Y? All right, I heard Z, so let's find Z first. To find this, can we use Pythagorean's theorem?
No.
Because we only know one side, right? So we have to use the trig stuff. All right? So using the trig stuff, we're looking for Z this time.
You can use any of those 2 angles.
Yeah, you can use either one of these 2, and that's what we're getting ready to do next. So next thing we need to do is pick an angle. Not the 90-degree angle, but one of the other 2. So pick me one. 42. So if we use this angle, now we're going to label the triangle in relationship to that angle. What's that side going to be labeled? Opposite. What's this side going to be labeled? Hypotenuse. And this is the adjacent. Now, when we're doing this, you got to be careful on this because I said, which side do you care absolutely nothing about? Well, this time we care about all the sides because we're gonna end up finding them all at some point, right?
There's a hypothesis.
But we wanna pick something that's got a number and then the variable that we're looking for. So we for sure want this variable because we said we're solving for z first, right? So we know we want to deal with the adjacent. Which other side do we want to pick to use? The hypotenuse, because it's got a
Go for it.
number. So which trig ratio deals with adjacent and hypotenuse? So we write cosine, what's our angle this time? 42 equals,
You have 542 for
z over 5, right? Now what's the first thing we do? Find cosine of 42, what is it? 7, 4 what? 3, 1. Z over 5, put that over 1. This is one of the nice ones, right? Because when we cross multiply, what do we get right here? Just 1z. When we cross multiply the other way, what do we get? 3.7. Anybody else get that? 3.7. Is that what it rounds off to?
Yeah.
So how long is this side right here?
3.7.
3.7. In this box, that's one of the sides, 3.7. Get rid of this z now, we don't need it anymore. That side is 3.7.
So then why would 2 be the opposite?
Now, we could, so now if you're looking for y, could we use sine, cosine, or tangent still? Yeah. What else could we use to find y?
Pythagorean theorem.
We could use Pythagorean's theorem to find it, because now we know 2 of the sides and we're looking for the third. Let's use sine, cosine, or tangent since we've already started. We've already got it labeled this way. We use this and the hypotenuse. Which trig ratio is it? So we do the sine of, what's our angle? 42 equals what over what? Y over 5. 0.6691. Y over 5. See, I use trig ratios all the time. I never use Pythagorean's theorem. We cross multiply, what do we get here? Y. What do you get when you cross multiply that one? 3.3. So how long is that side over there? 3.3. Let's use Pythagorean's theorem. What answer should we get for y when we use Pythagorean's theorem?
3.3.
We should better get somewhere real close to 3.3. So if I use Pythagorean's theorem, a squared plus b squared equals c squared. Which one's the c? The 5. So you got to make sure the hypotenuse goes in that spot. Got to make sure. We got 5 squared. What's the a? 3.7. We don't know the 3 yet, right? So that's the b squared. We don't know the 3.3. Well, that's what we were trying to find here. What's the first thing I did? Square. So grab your calculator. What's 3.7 squared? 13.69. Is that right? Oh, you're saying that. B squared equals, what's 5 squared?
45.
What is it?
45.
25. Now what do we do?
Track 13.69.
Subtract 13.69 on both sides. Somebody help me out. What's 25 minus 13.69?
11.31.
11.31.
Square root.
We take the square root.
3.4. 3.4.
3.36. Did we mess up on the other one and round it wrong? Because this one's going to round up to 3.4. Was the other one only 3.3?
Oh, no.
It's 3.34 something.
That's my
Why'd you do that?
It's 3.3455.
Care about focusing and not playing with Hunter's net. So on this one, it came out something like 3.34. What was 55? That 5 tells you what, do what to that 4. Round it up, and if that becomes a 5, then that tells us to do what to that. So it's pretty close to 3.4. I probably accept either one of those answers, 3.3 or 3.4, because it just depends on how you round it. Should be able to do that whole front page. Pick me one of the other word problems somewhere on the packet. Might want to read a little bit first.
Come on.
18.
I heard 11, 18. Who wants to see 11? Raise your hand. Who wants to see 18? Austin, they outvoted it. 18. A fireman's ladder leaning against the house makes an angle of 50 degrees with the ground. How long is the ladder if the ladder is 8 feet from the foot of the house? So 18, this is what you gotta be able to do. What am I gonna have to draw here? A what? Triangle? Explain to me some things from that problem. I'll stand up here for the next 20 minutes if nobody's.
Right.
What angle? Right angle where?
No, I put, yeah.
So that's a right angle. Give me something else. Here, let's even put some letters on here so you can tell me a little easier. C is what?
BC is 8.
BC, segment BC is 8 feet. Give me something else.
Angle ACB is 50.
50?
Yeah.
One more thing we need to know.
Oh, yeah.
Angle B, find out angle A.
Yeah, something else that what are we looking for? We don't have anything that we're looking for yet.
How long is the ladder?
How long is the ladder? Where's that go?
Oh, X is
AC, so we'll make that X. Can we use Pythagorean theorem to solve for X on this one? No. So we have to use the trig stuff, right? Could we use the 30, 60, 90 stuff? No. How about 45, 45, 90? Because we got a 50-degree angle, right? So we have to use the trig stuff. Which angle am I going to label my triangle off of? The 50. So tell me, without me drawing in the letters, tell me which each side's labeled, or drawing in the arrows.
AB is opposite.
AB is the opposite.
AC is hypotenuse.
That's the hypotenuse.
BC.
Adjacent. Which one do we? Which sides do we care about? Adjacent, hypotenuse. Which trig ratio is that? Does everybody agree? Austin, cosine.
Yeah.
Cosine of what? 50. So you go your trig ratio, your angle, your equal sign, then your fraction. It's adjacent over hypotenuse. What's the adjacent? 8 over x. We got our equation. Once we have our equation written, what's the next thing we do? Find the cosine of 50 on your calculator. What is it? Remember, not second. You're only doing second when you're finding an angle, right? Put that over 1 equals 8 over x. Is this going to be one of the harder ones or one of the easier ones? A little harder, right? Because you got to do 2 steps. What's that give us? 8. What do we get when we cross multiply the other way? Now what?
About 8 by 26, what you
These cancel out. We're left with x equals, what is it? 12.44 feet. So how long is the ladder? About 12.44 feet. It's probably not, because you don't go to Lowe's and buy a 12.44 foot ladder. I'm guessing if we came out with something more than 12, a 12-foot ladder would be normal. It's probably something more like a 15-foot ladder, and we just don't have it extended out all the way or something. But 12.44. One more question, then you're on your own.
11.
Is that what we want? It's 11 this time?
Yeah.
Get this done, you start working on the other problems, I'll walk around and help you as you're working on them. The angle from a tee box to the green is 10 degrees on a par 3, 185-yard hole as shown. How much higher is the tee box than the green? So they're telling us this. The angle of depression from the tee box to the green is 10 degrees. Now, we could just use this triangle, but they're trying to confuse you and they're saying, okay, how much higher? So they want to know this distance. Well, where else is this distance in my picture? So could we just use that triangle right there? Yeah. If not, if you wanted to use this bottom triangle so that you're on the ground, could we find this angle right here? What has to be true about this angle?
It has to be a zero.
This would be 10.
Is it 10? That one's
That's
10.
20.
No. It's fine.
With that,
What do we know about that point?
It's 90.
That whole thing's 90. What's this angle down here then?
it's 80.
80. Or we could do this and fill this in, and what's this angle down here at the bottom? That's 10 because they're alternate interior. But if we just use this triangle, we can do that. We can just use that triangle. That's 10 degrees. Now the bad thing is, they say this bottom part is 185 yards. Well, that's not in our top triangle. But we can transfer it to where? The very top up here, because this whole thing's a rectangle, and if that's 185, this has to be 185. What do we know about this angle right over here? Right angle. We're trying to figure out this side, how much higher the T is than the green. Can I use Pythagorean theorem on this?
No.
No, I have to use the trig ratios, right? Tell me how to label the sides.
Opposites
Opposites.
This is the opposite.
And then
Now, do we really have to label all three sides?
No.
No. Which other side do we care about? The 185 up here, right? And what is it?
Adjacent.
Adjacent. So then we're not even labeling the hypotenuse because we really don't care about it. Which trig ratio deals with opposite and adjacent? So we write tangent of what?
10.
10 equals what over what?
185 over X.
185 over x? I'm not looking at it, so I don't know.
X over 185.
X over 185, which one is it?
X over 185.
should be X, 'cause that's what it
X over 185, is that what we're going with?
Yep.
Hope you're right, because I'm not looking at it. What's the first thing we do?
Right there, there.
Find the tangent of 10. So grab your calculator, find the tangent of 10.
1763.
Say it again.
1763.
Got different answers.
There's, it's 0.1763.
Yes.
Oh, yeah.
Point what?
1763.
Point 1763. Everybody agree now?
Over 1.
That over 1 equals x over 185. Now what?
1x.
1x on that side, so just x. Cross multiply the other way.
I already used the answer. You just find
So what do you get?
32.6.
32.6 what?
Yard.
2.
Yards. So what's that telling us? Somebody explain that to me.
That's how much higher the 3 boxes in the green.
All right, so when you're standing up here at the tee getting ready to hit your golf ball, you're actually hitting downhill, and you're 32.6 yards higher than where your ball is going to end up, hopefully. You see a lot in golf, if you ever watched like it's not called the English Open. I can't remember what the name of it is. The one that they play over in England and Scotland, the ones overseas, they have a lot of tees where you're hitting a golf ball and you're hitting off of something real high down onto something that's a lot lower. No, just regular golf, but it's like this Scottish Open. It's not called the Scottish Open. It's got a special name, like the Masters or something like that. It's got a special name. I can't remember what it is. Wimbledon is for tennis. It's not called the English Open. Like we have the American Open for tennis that's played in New York. Well, the English Open is called Wimbledon. I can't remember what the names are, but we don't have a whole lot of this in the U.S. where you're hitting way downhill like that on a golf course. But in Scotland and England, where they actually have cliffs and stuff, they have a lot of that. You hit off the top of the cliff, you hit, and then your ball ends up way down somewhere else. One of the things I know in Scotland, you got like, you're way up on a cliff up here hitting the ball, and the green is right here, real close to the ocean or the Isle way there, whatever it is, right close to Scotland. Because you see people hit it, and their ball goes out here in the ocean, and there ain't none of this pulling up your pant leg and getting down in there and hitting it back up. It's gone. They give us this. We're looking for all the missing parts. They give us this triangle. Don't make fun of my triangle because I'm trying to hurry so we can get more done. 37 degrees. What's the first thing, the easiest thing to find? Find the other angle. Somebody find this other angle for me. 53 degrees. Everybody agree with that? How do you find it?
He took 90 minus 12.
All right, these two add together should add up to equal 90, or all three of them together should add up to 180. So that's pretty easy to find. Pick me an angle. 53. So if we use that 53 degrees, we're going to label this triangle. What's this side going to be labeled? Opposite. About this side. Hypotenuse. About this side. Adjacent. Which side do you want to find first? We know all the angles. We've got to find two sides. Which one do you want to find first? The opposite. So we're going to make this X. So we're going to use the opposite and what other side? The adjacent. Which trig ratio deals with opposite and adjacent? So we set up our equation. Tangent, what's our angle that we picked? 53 equals, tangent is opposite over adjacent, so what's it going to be this time? X over 18. Somebody help me out real quick. Tangent 53 on your calculator.
1.327.
Now, Allie got worried because she remembered that I said that something shouldn't be bigger than 1. Is it all right for tangent to be bigger than 1? Tangent can be bigger than 1. Sine and cosine can.
So like if one side's 9,999 and one side is 1.
We cross multiply. What do we get?
Good afternoon, National Control. Just have one
X
announcement
equals-
today. I want to say congratulations to the
Somebody do
boys
that for me.
baseball team as they play here against Eaton.
23.9
and
then?
girls travel at Union City. I want to say good luck to both teams. That
That's
concludes
one of the
our
sides.
day, So have a great day.
That's this
and
side.
go
Blazers! How do we find the other side? We could use sine, cosine, tangent. We could use Pythagorean's theorem. I'm going to use Pythagorean's theorem. 18 squared plus 23.9 squared equals c squared. Somebody do all this and take the square root of all that on their calculator.
29.9.
Anybody else get that?
No, it's called I've already done the work for it.
So those are our three answers. We solved that whole triangle. We found the three missing parts. On the other pages, we got 3 minutes left. On the other pages, you want to see me do one of these word problems? Yes, no?
Nah, we use.
Pick me one.
Okay.
I'll do it. Some of you don't have to watch if you don't want. 10. Problem 10. We got this triangle. They tell us the angle of depression is 20 degrees. If that's 20 right there, what's this angle down here? 20. That's a right angle. How far is he from the 600-foot point on the ground below the? You are in a hot air balloon that is 600 feet above the ground. So we're 600 feet above. They want to know how far your friend is standing down here, somewhere looking at you. Right? So that's the opposite. This is the adjacent. So which trig ratio? So we do the tangent of our angle, which is 20, equals 600 over x. Somebody help me out. What's the tangent of 20?
0.3639.
3639.
No, it would be 0.340. Why does it round?
Say it again.
0.340.
Like that. Equals 600 over x. Put that over 1, cross multiply. You end up with 600 equals 0.3400 x. Somebody divide 600 by 0.340. Should about triple. Should be about 1800. 3640. So 3640. Should still about triple.
1,648.5 feet.
That's not right, Ward.
That's not right.
So we're saying that this person down here is about 1,650 feet from where the balloon is right here. Does that make any sense?
Yeah.
Does it make
Yeah.
sense for him to be that far away?
Yeah.
Just do next time. No ifs, ands, or buts. Next time I will not do a whole bunch of